So now that we've discussed user and group management, let's explore file system permissions. So we'll label this section file types, permissions, as well as symlinks, symbolic links. Now in Linux, file permissions are represented by 10 bits. And the features include the ability to restrict / control access to files, which also includes directories. So note, 10 bits represent permissions for files, which also includes directories. And to examine those permissions, we use the ls command. Use ls with the long option to examine permissions, or GUI application like Nautilus, which is similar to Windows Explorer, and then you can navigate to the properties of a file or alter the output such that the permissions are displayed within the window that you are looking at. So we use ls-l wherever we are to see those 10 bits. And let's take a brief look and extract something from Linux CBT's home directory. We don't need to be root, so let's just drop out of the root shell and execute lsl. So here is the test rh5 subdirectory. We can work with an item that we recently created, the regex test.pl file. Let's copy this entry and discuss the 10 bits that constitute permissions. The first bit, in this particular case, since it's a file, is a hyphen or is unmarked, indicating that the item is a file. So bit 1, or first bit, equals file type, where a hyphen means file and D is equal to directory. But there are other types of files, such as named pipes, devices, and others. But for our intents and purposes, files and directories are simple, and we come across them more so than other types of file objects. The second bit, in fact, second, 3, and 4 control permissions that are associated with the owner of the object. So second through 4th bits equal owner's permissions. And those permissions can be organized in any of the following: read, write, and execute. Now each of these permissions bits, read, write, execute, which we see for the file object regex test.pl, also has an octal representation. R is equal to read, but it's also equal to 4. W is equal to write, but it is equal to also 2 in octal notation. And last but not least, to complete the octal representation, which must add up to 8, thus the name octal, execute represents, or is represented by 1. When we add them all up, 4 plus 2, 6 plus 1, 7, we get the full bit representation, or total sets of permissions that can be assigned to the item. Now you may be wondering, doesn't add up to 7. Well, if the item isn't flagged, it occupies position 0, so 0 through 7 represents the octal set. As you see with the case of a file where there's a hyphen, this particular item, or this bit, is currently on set, occupying the 0th octal value. So read, write, and execute are the permissions that are permissible within a Linux file system, regardless of file system type. So it can be riser, ext2, ext3, jfs, xfs, you name it. These are the types of permissions you may set: read, write, and execute, and they have the values 4, 2, and 1. Bits 2, 3, and 4, or second through 4th, correspond to the owner's permission. Now when you use long format to return the permission information, we see the owner of the object immediately following the number of symlinks. So this user, Linux CBT, owns the object. Bits 5, 6, and 7 represent the group owner's permission. So 5th through 7th bits equals group owner's permissions. And here again we have the same permission sets, read, write, and execute. So it follows through nicely. And we wrap up with the last sets of bits, 8, 9, and 10, which represent everyone else. So 8th through 10th bits equals everyone. In other words, the world, anyone who has access to the file system, whether via Samba, NFS, or locally connected using SSH, Telnet, etc. The 8th through 10th bits also can be read, write, execute, but they also may be hyphen, and we should just include that hyphen equals none, which is equal to 0. So for each of the groups you may see hyphen, which indicates none or 0, with the exception of the first bit, which represents a file if there's a hyphen. Now there are tools that allow you to influence or change the bits associated with a file. For example, looking at this regex test.pl file again, we changed the permissions to make the file executable because we created it as a Perl script. We can remove the permissions, the execute permissions, for example, using the change mod command. So task, manipulate file permissions using change mod. Change mod changes the mode of permissions on files. Now to remove the execute permissions, we can do the following. Change mod. Now before we added using simply plus execute, we can minus execute, followed by the name of the file regex test.pl. And if all goes well, when we relist the contents of the directory, the file will no longer be executable. That's lsl regex test.pl, and there you see the execute bit, or the bit which occupies the last placeholder, which is also equivalent to 1 for each of the groups of owners. The owner, group owner, and everyone else has been unset. So now the permissions have been changed to simply read, write, read, write, read. These permissions can be converted to octal notation and reference, especially when communicating between administrators. So now when we look at the file, it has the octal representation of 664. For the owner, read plus write equals 2, or equals 4 plus 2, which equals 6. So read write equals 6, or 4 plus 2. And that applies, of course, to the owner of the object. Ditto for the group owner. However, we have simply read, which is equivalent to 4 for everyone else, or the world. And that's how we come up with octal notation of 664 for this file. Now this 664 can be passed to change mod to influence the permissions of the file. For example, change mod 664 regex test.pl achieves the same thing as removing the execute permission from the file. And conversely, if we wanted to turn on execution permissions, we could indicate change mod 774 to influence the permissions, or 775 so everyone can execute the file. So this enables execution for all users, and this removes execution for all users. Let's give it a try. Currently execution has been removed, so let's reapply it. We'll re-lsl regex test.pl, and now we see execute has been turned on for the owner, the group owner, in this case bits 2, 3, 4, 4, 5, and 6, And for everyone else, read execute. Write has been skipped. And whenever the write bit is not present for obvious reasons, the user who is within that context, such as everyone else, will not be able to write to the file. However, we're logged in as the group or the user owner, the owner of the object, so we will be able to write to the document. So now the file is flagged as executable by all users. Let's remove the executable permissions by setting 664. And then we'll use command chaining to lsl regex test.pl, where you see execute permissions have been removed. So this way, it can no longer be executed by default unless we reference Perl first, followed by the name of the script. So long as you memorize that R is equal to 4, read is equal to 2, and execute is equal to 1, you can combine the permissions as you see fit. So for example, let's suppose another task would be to make regex test.pl readable and writable by the owner and no one else. So next task would be to ensure that regex test.pl is readable or read-write by owner and no one else. To do so, we'd execute a change mod, and if you think about it, read plus write is equivalent to 4 plus 2, so we know we need 6, because the 6, or the first value, corresponds to the owner of the object. We want no other user, including the group owner, to have access to the file, so we simply turn off all bits by indicating 0, and ditto for everyone else. So 600 will make this file readable and writable only by the owner of the object, with one exception. And that exception is the root user of the system, or a root equivalent. So change mod 600 regex will do just that. And we should note, file will now be RW by owner, and that happens to be the user Linux CBT, and root, as you are unable to lock root out of a file. The interface, for example, may say you're unable to read it, but root can always change the permissions to the file. So let's execute the change mod, and then lsl regex test.pl, where you now see most of the bits have been wiped out, with only read-write, which applies to the owner of the object. We know because the read-write permissions are in positions 2 and 3, which correspond to the owner. 2, 3, and 4 correspond to the owner. 5, 6, and 7 corresponds to the group owner. 8, 9, and 10 corresponds to everyone else. So let's test this all out. Let's nano regex test.pl, and we'll insert a comment at the bottom. And we'll try to save the document to be sure that we can update it. Notice Nano had no problems updating the document. We can LSL, compare and contrast between the current timestamp, and it has worked as expected. Now how about if we attempt to modify this document as someone else, such as student 1, from a separate shell? We'll SSH as student 1 to the local host, which will prompt us for authentication. Now we're in as student 1, in student 1's home directory. Let's navigate to home Linux CBT test RH5. And it doesn't let us interact with the file. It doesn't even allow us to navigate into the directory. Let's take a look at the permissions one level up to see why that could be the case. So we'll lsld test RH5. And the directory is readable by everyone else, so let's go one level up to the Linux CBT directory, and that's why. The Linux CBT directory is not readable by the user, or other than the user owner as well as the root user. So with that said, we would need to move the file or change the permissions on the directory. So if we wanted this directory to be readable by all users of the system, let's navigate one level up and do so. We'll change mod 755 Linux CBT. Now we have relaxed the security, and student 1 should be able to take a look at it. Let's lsltr home Linux CBT test RH5, and now we can interact with it. So with that said, we will nano regextest.pl, which currently is set to 600, and you'll see permission denied. Error reading home and the full path to regextest.pl, permission denied. Now how about as root? Let's log out of this session, and now we're in as Linux CBT, and then SU in, and try to interact with the document.